Hey guys, welcome back to the next video. In this video, we're going to talk about different cluster architecture in your load balancer. So you have round robin, weighted round robin, random least connection. You have hash-based load balancer, which includes LB, session ID, and URL. And then you have response time-based load balancer. In a cluster, load balancing is so important. And as important as load balancing, you need to understand the algorithms in terms of load balancing. We are going to understand all these algorithms with a live example, and we are also going to understand, which is the suitable for which situation. Round robin is suitable for most of the situation because it is, if you have servers, as managed servers, or servers, physical servers or virtual servers, which is configured with a similar amount of RAM, right? So if you're on an infrastructure where you have similar amount of allocations of RAM to each of the servers, and your managed service also has the heap allocation as the same, then I think you should go for a round robin method. Using the round robin method, you can see the request 1, request 2, request 3, request 4. So it basically, request goes to each server once, and then it keeps repeating the same process without any kind of a logic here. In terms of weighted round robin, so you're going to have weights or distributed across your managed server. Now, let's just say in ideal situation that in our environment itself, we have managed server 1, managed server 2 hosted on one host, which is WLS node, WLS host 1. And you have another server with WLS node 2, WLS host 2 hosting MS3, right? Which means that here you have two processes running on one server. Here you have one process running on one server. If you understand the resourcing point of sight, this has less resourcing compared with this one. This has managed server 3 has more resources. So we have given a weight of 2, and managed server 1 and 2 has weight of 1, which means that the request 1 goes here, request 2 goes here, and satisfy the weights. And when the managed server 1 and managed server 2 handles one request each, managed server 3 will have to handle 2 requests. So the third and fourth request has gone to managed server 3. In this way, based of the weightage over here, the number of requests will be split. Sometimes people give 50, 50, and 100. So that is also the same thing, what I told you. So every time this one handles 50, this one handles 50, this will handle 100 requests. So it will take twice the request. So normally we try to give the lower number so that it avoids confusion. If you give higher number, there's a lot of divisions and subtractions required, and it takes a bit of time to get there. In terms of random one just sends the request randomly. It has no favorites and nothing, or it doesn't work on any kind of a logic. So it just randomly sends the request to the managed servers. And I don't see any reason why people use it. So mostly it's just there just to, just be there. So I don't see any real-time use cases for random. In terms of least connection, it is also nowadays popularly used. Least connection and as well as response times more or less the same. Least connections will actually look at the number of connections established in your each managed server. So for a managed server with the least number of connections, for example, all those connections here is all completed and you have just 10 connections. So all the requests will go here so that it will create new connections. So this is basically least connection. And response time is basically the same thing. So it looks at the response time of this managed servers and then basically assign those requests which has the least response time. So here it has 1 milliseconds response time. So according to the logic over here, it just sees that who is responding faster, which means that they are free. So it will just basically assign those new requests to that server which has a least response time. When it starts taking more requests, then the response time becomes nominal, and then it will look for another lower response time and basically assigns those new requests to that server. In terms of hash-based are a predefined, predefined methods which the URL or your IP address who you're browsing from or your session ID carries, which says that, okay, if this comes, then it needs to go to manage server 1. If this comes, it needs to go to manage server 2. Likewise, you have predefined method of carrying forward, and then that manage server will take care of that request. So WebLogic cluster can be configured with these kind of clustering algorithms, and your load balancing can also determine based on these kind of algorithms as well. This is what I wanted to cover on this video. Thanks again for your time. I'll see you on the next video.